Don't forget to make use of the alarm matrices or matrices. It's pretty easy, pretty quick to draw one up. This one we're looking at has energy losses in the distribution of electricity in the grid, and possible new technologies might limit or minimize the loss of power in the grid, electricity grid. And our definition is just about energy loss. The transmission of power stations to their factories, energy loss is proportional to the amount of current sent. So it's always advisable to increase the voltage and not the current when you're sending electricity over long distances. And you can see that from the power equations. So P equals VI, we know that. We also have V equals IR for Ohm's law. This is our power, this is our voltage and current and resistance. Instead of having voltage here, we substitute in IR and we get P equals I times IR, which equals I squared R. And this is the equation for power lost, or the power that in going through a wire you're going to increase power loss. And if you do have a large current, you can see the current squared times the resistance. So the bigger the current, the more power loss. If you can minimize that current, and you do that by using transformer. So if we use a step down transformer or a step up transformer, so in this direction is our AC current. Remember, transformers need AC current, and here's our measurement of the voltage in the secondary circuit. So in this case, that's our primary circuit, and that's our secondary circuit. So in stepping the voltage up, on both sides of this equation, volts, power in has to equal power out, or V primary, current primary has to equal V secondary times current secondary. Now we know there's going to be energy lost due to eddy currents and heat, etc. But you can start using these equations. We also know the number of turns in the primary over the number of turns in the secondary is proportional to the voltage. And this equation is on, as well as the power equation, they're on the formula sheet, and these are number of loops in primary, number of loops in secondary. So make sure you look at that before you do that. Okay, so here we've got our identifications. We've got transmission grid. We've got energy is lost during heat, transformations, traveling through wires, anything that's metal that you put electricity through, it's going to heat up because of resistance, mild resistance maybe, but resistance in metals. We also have possible new technologies. This is the one we're evaluating. To describe it, we're looking at this, the metal structures in the grid, poles, wires, leakage, and maintenance. Energy is lost continually. You have resistance of wires, you have eddy currents producing, you have transformers, reducing the current that's sent to local substations. So we have step down transformers. We also have step up transformers to get the power, the voltage up and the current down, and then sending it over long distances. We've also got these new technologies, and the main one we're thinking about here is superconductors and high temperature superconductors, so that would work at room temperature or higher. They don't exist yet, so that would be an analysis. It will be a minus. They're getting higher and higher, the temperatures, but you're still looking at minus 180 or so degrees C. You can convert that to Kelvin. Remember, 273 minus 273 degrees C is 0 Kelvin. Our explanations, we can go into the voltage, talking about putting the voltage up, current down when it's sent through the grid, The power equation you can have in here. Transformer efficiency you can put in there, just explaining why there's energy loss or how it's lost. Superconductors, a lack of resistance means that energy can be transported much more efficiently. You're not losing it to heat. Our analysis, we can talk about the grid, its design, and that it leaks power. We have to put a lot of energy in at one end to get out what we need. We use transformers all along the grid. Step up, then along the grid, then step down, substations, step down again for houses to make sure we've got the right voltages. When you step down on a transformer, remember the current goes back up a bit. Power in equals power out. VI equals VI, remember. The efficiency of transformers, the loss, you can mention eddy currents there. Superconductors are not yet available. So we're analysing that with respect to the grid and the idea of energy losses. We could do a lot more of these, but we're just looking at 3 here. Critical analysis. The transmission system in Australia is quite old. It's expensive. You've got leaks from downed wires, trees touching wires. You've got so to suggest that you're going to minimise the loss with the same grid is not really. So here we're looking at analysis and we're going into pluses and minuses and getting a bit more in depth. Transformers, while they increase the voltage, they also lower the current. They can get hot, so you're losing energy at that point. Superconductors, if you could have one, they're not existing really yet, but they're very expensive, they're very brittle, so you're not going to be able to cover large distances. And then we've got our evaluation. So can we limit energy losses, distributing energy in Australia? These new technologies, are they coming online? So here we're evaluating and justifying whether those things are possible. Expense is a big issue at the moment with electricity in Australia. Transformers, the efficiency of them, they haven't been developed nearly as much. They still produce heat. It's minimised by laminating the core, but still producing a lot of heat. And it's not practical to cool down large areas of the network to allow superconductors below their critical temperature. So in an overall evaluation, there's room for improvement. We can update the grid. We can reduce some of the losses of energy in our grid, but superconductors are not really the answer at this stage. We're going to have to continue to lose energy, maybe because we've relied on power stations being away from public areas. We're using AC current to transport. Those power stations far away, we can't really move them closer to human populations because of pollution, and they take up a lot of space. So we've got a balancing act. We're always going to lose energy if we transport over long distances. That's energy loss is proportional in wires to the surface area, the cross section. Energy loss is proportional, so thin wires will let less energy through, more resistance, higher temperature loss. Long distance, impurities, all these things go into losing energy in wires. Updating our grid all at once is not possible because of the cost. Transformers need to be kept working in good order. New technologies in transformers could be an area that we could use because whenever they're replaced, but the possibility of using superconductors, unless there's a breakthrough, is not really a viable option. This information used in this sort of matrix, so it's to get a longer, more detailed answer in the higher question marks. I want you to, if you get a question that you need to do this sort of thing, use a scrap bit of paper. If you can't remember the top sections and the bottom sections, at least put your answers into these sections and try and formulate a better quality answer Remember, we want to get up here to get our higher marks, our bands 5 and 6 marks. If we get to this point, that's alright if the question is that's what it's wanting, or an explanation, or just a description or list or outline. But often questions will ask you to analyse or evaluate or justify. Remember, if you're asked to justify, evaluate, you've got to give a judgment. So my judgment was the grid is going to be losing energy for the foreseeable future. It's not possible at this stage to transfer over to superconductors. They're not possible, and so we can't really limit our energy losses in as part of the grid. Energy losses in the home, more efficient production of energy, that's possible using nuclear technology, etc. at the power station. Government's going down the path of clean coal, etc. So it's a good way to get your thoughts into your head and get things sorted out. Okay, you can leave those questions to the end if that's what you want to do. Just keep an eye on the time though. Okay.